Okay, this video is going to be about the ruler. Now, I'm going to show you this ruler that I have. In our engineering division, Eric Woolridge actually used a 3D printer, and you can see that it's thick. It's actually made out of plastic, but it's tactile because you can see when I turn it sideways, the little markings are raised so that someone could actually feel the ruler, especially someone with limited vision. Okay, and if you look at the ruler, each of these markings represents 1/4 because you have 1, 2, 3, 4 little pieces in between each, representing each inch. So 4 pieces means each is 1/4. Okay, just showing you that whole notion of a ruler. Now, this activity is one of the best activities that you can do when you start to really look at measuring things and having to determine whether something is 3 1/8 inches, 4 2/16, or whatever. And if you take a look at most rulers, and strangely enough, my rulers always walk away, and I don't actually have one that looks like a real ruler. But if you take a look at a real ruler, most of them are actually marked down to 16ths. So what we're going to do is we're going to fold, and we're going to make a pseudo ruler. And I call it a pseudo ruler because obviously the measurements are not correct in terms of inches. Now, this piece of paper that I have, just so you can see, this is a normal size sheet of paper, 8.5 by 11. This is a sheet that's, I think, 11 by 14, and I just cut it with a paper cutter. You can cut and use an 8.5 by 11, but it's more difficult because the numbers get closer together. Alright, so we're going to take, by the time you do fractions with children, they're going to have a good base knowledge. by the time we do measurement with children, they're going to have a good base knowledge of fractions already, because we're not going to attempt doing measurement until we know that students have a good understanding of fractions. So if you did the paper folding activity that I did in Math 205, which models this somewhat, what happens is with the paper folding activity, we would fold one piece of paper. We cut strips first of all the same length. So take like an 8.5 by 11 sheet and cut them in strips that are about an inch, inch and a half, so that they're all the same. And then you fold it in half, and then you would draw the whole mark, and then mark this one half, this one half. Then take another strip, fold it in half, and then fold it in half again, so it's fourths. They're all the same length. So what you'll have when you're finished is this big long stack of strips that you could lay on the table. The first one's a whole, and then a half, and then halves, and then fourths, and then eighths, and then 16ths, so that you could actually see the markings. So now, having done that in the class when you did paper folding, we can just kind of review that and say, okay, now on a ruler, if you take a look, you see that all of the markings are different. So a half, in other words, the bigger the piece, the longer the mark is on the ruler. And you actually can see that from the ruler that I have here. Alright, so I'm going to label this. Then over here is 0. Over here is 1. And I'm just going to write 1 up at the top. And this represents 1/2. And I'm going to write that down there. Okay, now, if I fold this like our paper folding activity, fold it in half again, and open it back up, then I'm going to put a mark that is shorter than the one I originally made, and I'm going to use that same mark for each of these. Now, these don't have to be exact, they just have to be shorter. Okay, so I'm going to do this one about the same length, because pieces that are the same size have the same length mark. Now, each of these pieces I have to mark in terms of fourths, because each one of these marks represents a fourth. So this one is 1/4. Then when we get to a half now, it's 2/4. When we get to this one, it's 3/4. And then 1 whole in fourths becomes 4/4. Okay? Now let's fold it in half again. So we fold it back up, fold it in half again, and open it back out. Now, these, we took a fourth, cut it in half, so now it's going to be eighths, so we're going to make it smaller again. So I'm just going to go through here and mark each one of these folds shorter than my fourths with all the same markings. All right, now each one of these represents an eighth. So now I have to mark each fold as eighths. So this becomes then 2/8, 3/8, 4/8, and I'm going to have to put it out here, and that's okay. 5/8, 6/8, 7/8, and 8/8. Okay, now rulers typically don't go any further than 1/16, so let's fold it one more time. And this is what gets difficult, because when you fold it up so small, okay, I'm going to run a pencil over it. So, and you can see from my fold here that they're not going to be exact, and they don't have to be. But what it will do is it gets you used to seeing, gets children used to seeing what they are. All right, now we're going to mark it shorter than the eighths. So we're going to go here, 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 and here. Okay, that one's a little bit long, but we won't worry about it. Okay, now we're going to mark these. This is 1/16. The next fold is 2/16, and it's already got a mark there. But notice what's there. We'll talk more about that in just a minute, though. 3/16, 4/16, 5/16, 6/16, 7/16, 8/16, 9/16, 10/16, 11/16, 12/16, 13/16, 14/16, 15/16, and 16/16. Okay, now this is all we need to understand what a ruler's measure looks like. Now, I'm going to zoom in here just a minute, a little bit closer, so it's easier to see how these are marked. Can't see the whole ruler, but what I'm interested in is you being able to see each piece. Let me tune this a minute. Hopefully the fuzziness is going to go away. There we go, that's much better. Okay, so now we know that this is 0. This represents 0 over here. Okay? Now, keep this in mind, guys. When you look and go to each subsequent mark on a ruler, it can be shown as, so like if you start with the smallest or the shortest line on your ruler and you count the spaces. Now so you're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 spaces in my ruler. So that means that each space, each little whole space here represents 1/16. Now keep that in mind, because if your ruler only has 4 marks on it, or 4 spaces in here, there would actually only be 3 marks then in between 0 and 1 or 1 and 2. But that tells you what the denominator of your fraction is. So then you always, though, want to think about going to the largest mark and seeing how many of those, how many spaces that's divided into. For example, if this is my ruler, the longest mark is this one, and it cuts 0 and 1 into 2 spaces. Okay? So that kind of helps just a little bit. All right, now let's look at this. Let me draw a ruler for you here just a minute. Let me zoom this back out. All right, so let's say this is my ruler. And let's say this ruler is different, okay? So let's say this ruler is marked off like this. Okay, now obviously I don't do a really good job in measuring equal pieces. Okay, so this is 0 and this is 1. So I have 1, 2, 3 pieces. So each of these represents thirds. So I would call this one 1/3, this one 2/3, and then this one over here represents 3/3. Okay? Now, if I cut these in half and made a little smaller piece, now notice I'm not folding, and that's okay. I don't need to fold now that I've got the concept. So I start out with the long marks, and I have 3. Then I cut them in half, and then half, that means you're going to double your denominator always. So then this becomes 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. Okay? Now, let's say I have one more mark. So then that would look like this. Okay, and it's shorter. So it cuts this in half, so it doubles your denominator, makes this 1/12. So then this is 2/12, because we're always, each mark is labeled with this, with each number. So then I have 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12, 10/12, 11/12, 12/12. Well, it would help if I could write. Okay, now let's zoom in here just a minute and look at this. Let's see what's really cool about this. Now, even though I divided this in thirds, I ended up having 1/2 in here, because when I cut thirds in halves, that gives me 6. So anytime I have even denominators, that means I'm going to hit that half mark because it divides by 2. So in 6, 1/2 would be 3/6. In 12ths, 1/2 would be 6/12. Okay, now keep in mind what you've got here. So when we went back to our original ruler, and let's look at this mark that ended up with these. All right, this mark of 1/4 ended up 1/4. Here are all the fractions that end up here. 2/8 and 4/16. All right, now let's see what happens. We know fractions, so we know that we can reduce. This one is in lowest terms. This one's not. Both the numerator and the denominator here will divide by 2, and then this gives you 1/4. Both numerator and denominator divide here. Now, this is something that's a misconception. It's a misconception to think that to reduce to lowest terms, one has to take the largest number that divides. You don't. Just pick one. Okay? Typically, in my math lab or on things, it will say reduce using the greatest common factor, but you don't have to do that. I could look at this and I say, I know that it divides by 4, but I could not be thinking and be in a hurry and see, oh, well, it divides by 2, which 4 divided by 2 is 2, 16 divided by 2 is 8, which then still divides by 2 again. Okay, so then you get 1/4. Now, you also could simply have divided by 4 initially and gotten 1/4. Okay, it doesn't really matter whether you use the largest number or the smallest. So that is the ruler explained just a little bit better.